like, it looks pretty level. I think if you go up in a tall building and you look out at the same ocean, it's still level.
Does the horizon always rise to eye level?
I don't know if I agree with that line in particular because it's kind of become a trope, But
Yeah, I
I think
agree.
like I think like atmospheric shit happens where
What
people
about
are
on a
still like,
clear day?
well, I think you're still dealing with heat, or you're just dealing with a medium. It's like the Weather Channel. The Weather Channel tells you how far you can see.
Have you ever seen this image here?
Oh, I don't know. So late, I gotta go to bed. I'm thinking, man,
Yeah, I get you, man. If you
what is
wanna,
it here? Let me see. I don't know if I've seen that one.
okay, I can elaborate. This
Is this
image
the
was
one
taken
where
in.
is this the one where you
Yeah.
ask me if there's a straight line?
They compress it.
No,
Yeah, you can compress it and it makes it look curved.
Well, no, is that what this is? Because I've
may,
been through
may I?
this before. I've been through
Yeah,
all this shit, bro. I've seen it all
may,
pretty much.
okay. May I go through my 40-second spiel with this for the audience?
Yes, sir.
So this was taken in Ibiza, and I've got all of the coordinates and the person that took it. Known straight edges are on the left side and the right side, balanced on this green table in the background. And as you can see, if you zoom in on this particular photo, you can notice that the horizon is split evenly to a degree. It's all encompassed within the two metal bars on either side of the table. You can gather the horizon there. When we squeeze or compress it, as Gio said, when we squeeze this photo to further accentuate what's curved and what's straight in the image, we get something like this. And we're looking at the known, quote unquote, known straight edges, aka the red lines that will be most obviously straight towards this. We can see that those known straight edges are in fact straight. And when we look at the horizon, the known horizon, or the unknown, as it were, appears to be curving. And the question is why?
I think possibly refraction with the coloring of the bar and the way that they, I would say again, it's like light is so malleable, and I think like,
Squeeze this photo to further accentuate what's curved and what's straight in the image, we get something like this. And we're looking at the known, quote unquote, known straight edges, aka the red lines that will be most obviously straight towards the center of the frame, as with any photo. We can see that those known straight edges are in fact straight. And when we look at the horizon, the known horizon, or the unknown, as it were, appears to be curving. And the question is why?
I think possibly refraction with the coloring of the bar and the way that they, I would say again, it's like light is so malleable, and I think like, I don't think when you start delving too far into this, like, because that, I just think it's a reach to go into. I'd like to know where
You,
those
fi-
little stills are kind of like from in the bar, wherever
And
that is from. But I really, it's so ridiculous though. It's like,
I would be. I
it's
appreciate
just,
your input.
I just say it's not convincing enough.
well, also, I
Seriously,
mean,
I've never heard
the
your
claim is
explanation, Gio.
well,
Yeah.
there's all the claims that you can't see the curvature from ground level too, in terms of that you can't see the curve from the ground. So this one shows. I mean, compressing it like that looks very curved. I would say two things. One thing real quick, like Jaronism, he actually had did a bunch of videos and things on this, and I don't know all the exact details, but my understanding is that you can take something that is absolutely measurably flat and you can compress it and it'll look curved. So I think it has to do with the compression. Although I don't know like the nuances of that entire argument because I haven't really done it myself, but I've kind of seen it over the years. So I have heard that you can take something that is absolutely flat, compress it, and get it to be curved. And I think actually Jaron of all
That's
people.
not true, Gio. The claim is not that you can't
Let me
see.
finish.
Let him finish.
Why are you
Hold on. Let him
interrupting?
finish.
Why would you do that when in the middle of me speaking? You can respond, have your time, but why would you just bowl over me? Please don't do that. I was right in the middle of speaking, bro. Anyways, that's one thing is that I've heard that when you compress it, you can a flat thing, you can have it look curved. And then secondly, when you're on a planar Earth, if you're seeing in a circle and there's a limit to that circle, like the limit of how far you can see or how far the environment allows you to see, you're going to see in a 360-degree circle like a hula hoop. And if you put a hula hoop like around your head at eye level, it'll look totally flat. But if you lower the hula hoop like 2 feet below your eye level, like maybe where your chest is, it will look curved. You'll have left to right curvature. So, and actually, even on a globe, like Jeremy talks about this argument, on a globe, the horizon, if you were to put a hula hoop on a globe, it actually also, all those points of the hula hoop lie on a plane. So there's even Zanuck, if he's in here, will give this argument that when the claims of left to right curvature are not actually the curve of the ball, because that the hula hoop of the horizon, even on a globe, is flat. All those points lay on a plane. But so that's a whole nuanced argument. But I'm just saying that the fact that we see, I mean, that you would be see in a circle on a planar Earth, meaning just like with the hula hoop thing, it could look like you have that left to right curvature, but it's actually just the circle of your vision or the circle of what you can see. a flat circle that could look left to right curve and not actually be the curve of the sphere. But yeah, go ahead.
Go ahead, Jake.
I was just going to say, no, you can do this test all you want with a straight line and compress it from left to right, and it's not going to show a curvature. Nobody says that you can't see the curvature from a low altitude like that. It's that you can't, with the human eye, you can't tell that it's curved in the same way that the human eye can't look at a warped motor, at the head of a motor that's warped, the deck is warped, and be able to see the curvature. You have to hold it against a straight edge and look for light coming through the crack to be able to see that it's warped, because you can't determine straightness to that degree with the human eye, right? But if you use a tool, you can easily see whether it's warped or not.
Okay, well, so first to address the thing. So like I said, my understanding is that you can take something absolutely straight and compress it and get the curved effect. Is your understanding that that's not the case?
You can just do it yourself. You can just do it in Paint or pull up in Photoshop. You can just do it there.
Yeah, I stated I have not done it myself. I think there's nuance to whether you use a camera, whether you use an image. We're not talking about just like an image on your screen. We're talking about most likely more of a camera. The camera is going to have some curvature to the lens itself, and there's going to be some of that effect. And when you compress it, it becomes more magnified. Like I said, I'm being intellectually honest. I haven't done it myself. I've seen a few videos on it, and I've heard the claims, so I'm just reporting.
Yeah, real quick too. The problem with the fucking globe trying to point out like curvature at this level and shit is that also like it doesn't scale out. So like if you have 1 degree of curvature at 69 miles and you're looking at like a little piece of section of the beach and you're gonna say that there's that much curvature, it just doesn't fucking map out. Like it doesn't scale out. Like especially I've always been fascinated with the idea that they talk about you can navigate 600 nautical miles as flat, and that would be almost like that would just be weird if the Earth was curving as much as you guys propose in this fucking these photos. If you know what I mean, like it seems like it's too drastic. It's such a contradiction of like practical usage of shit versus this theoretical boats are going over the curve of the Earth hill you guys are dying on. It's so weird. Like you know what I mean? Like it just doesn't scale out, man. If you're gonna say that, then you can't have that. And the problem with in this instance is that part is everyone navigates 600 nautical miles is flat, so there's no scale. It doesn't work. If you're gonna say that, then you can't have that. And the problem with in this instance is that part is everyone navigates 600 nautical miles is flat, so there's no scale. It doesn't work. Does that make sense, or did I miss a topic?
Well, my question is, why is it curved, whether it's flat or globe?
Because light is malleable and is affected by heat and atmospheric density. You know what I mean? Whatever the fuck you want to call it. Like, that's
Well,
why, and that's way more agreeable.
And what I said about seeing in a circle, I mean, that the hula hoop effect. Like if you take a hula hoop and put it on the floor, on a flat floor, and then stand in the middle of it, it's going to look curved left to right. Or if you lower it, below your eye level. So, and like I said, that on a globe Earth, even if it was a globe, okay, let's say you're up at high altitude and it's a globe. From the globe perspective, from your feet to the horizon, there would allegedly be curvature. Like from below your feet, all the way to the horizon, yeah, there would be a curvature there. But if you're just looking at the horizon line, all those points lie on a plane. They're planar. So the idea that any left to right curvature on a globe is the curve of the ball is just not valid. And like I said, Zanuck will support this argument, others as well. Because like I said, if the actual horizon itself, all those points lie on a plane. And that could look left to right curve, just the way that a flat hula hoop will as well, because you're seeing in a circle. You're just seeing above a circle, and you're seeing the effect of that circle around you, whether you're on a plane or a globe. The only difference is that the globe is going to have curvature from below your feet to the horizon, yes. But I'm just talking about just referencing the horizon itself, 360 degrees around you.
Yeah, but be honest, we're talking about I don't know, 40 degrees maybe that's gathered out of the 360 degree circle that we would be on, and it's most certainly curved in that 40 degrees. I hear what you're saying about the hula hoop, right? But on a flat Earth, that is, this is taken in Ibiza. So if we look on a flat Earth map, right? Like, we don't have to go this route, but like, we're talking about um, Ibiza. We're talking about a lot of map that's unexposed, that's fallen off, right? That's my point.
That's fallen off, you said? I didn't
Yeah, we're talking about we're talking about in Spain, right? Like, so if we're looking towards the edge of the Earth, that would be a flat Earth. Again, I'm I'm talking about like a flat Earth that is. Let's talk about the North Pole at the center, and I don't know that there's anything other that's been reported that could be at the center of the flat Earth, but like this is like pretty close to the center when we're looking out, and it's falling off as a curve, and like we're supposed to believe that not only is Africa missing in this photograph, like looking towards the south, right? Like it's just gone, like it's just a curve of water.
No. Well, see, I mean, my view of that on a planar surface, you're only going to see a portion of it. So you can see a lot more of the sky, but the ground level, like, you might see 3 miles to the horizon, maybe 10, maybe 20. I mean, the longest distance world record photography is like 300 miles. Jay Tolan has claimed on his channel that when he's gone up to high altitude, that he can see as far as 1,000 or even 1,500 miles. But that's still quite a small portion of the Earth, considering. So I mean, I think he was like, saying that he was seeing like, like the Hudson Bay from somewhere around near like Ohio or something to that effect, like in an airplane. So we're still talking about a pretty small little portion because the ground layer is going to be limited by all kinds of factors. I mean, you have clouds and rain and
How far did he
just
say that you can see the horizon? 3 miles,
well, I mean,
5 miles or something.
well, I mean, yeah, if you like on like a classic weather app, you'll get visibility. But I mean, yeah, usually depending on your altitude, the conditions, I mean, sometimes it's less than 3 miles, but I mean that often you could see something like that. I mean, I don't know what the average is.
I'd agree with
But
that. Yeah, I think you're right. But why can we see the stars? They're certainly even if they're on the dome or the firmament or whatever, like they're further than 3 miles away.
yeah, so like, okay, if the distance from the equator to the North Pole is what is claimed, 6,210 miles, which would be fairly easy to verify. Somebody could go to the equator. You can drive your car all the way up, middle America, up through Mexico, up the United States, up through Canada. You can get to like 80 degrees north. So you could go from the equator to 80 north and measure that. So, I mean, I think for them to hide that distance, like, because the Gleason's map claims it's like 4,000 miles, like 3959, whereas on the globe claim it's 6,210. Also on the dual pole, it could be the 6210 because you don't have the equator as a circle around the North Pole on a dual pole layout. But either way, if that distance is 6,210 miles, well, that's when Polaris disappears. So if we can see 6,210 miles of the sky as a radius, if you make that a diameter, you got about 12,000 miles, which is about half of what they claim the globe is, because the about 25,000 mile, 24,901 of the circumference of the globe. Well, half of that's 12,000. So a 12,000 diameter of what you can see of the sky would make sense with that model. And how that works on a planar Earth as well. But if that's the case, then let's just say you can't, because Polaris sets at 6,210 miles, if that's the right distance. So let's say we can see 6,210 of the sky, then that's what we can see of the sky. Let's just say for the moment. But the ground layer, you might only see 3 miles, 10 miles. You know what I mean? So you might see, let's say, 50 miles in certain conditions at a higher amount. So you're seeing 50 miles of the ground, but then you're seeing 6,210 of the stars. So you're seeing a lot more of the stars, but the ground, there's just so much. I mean, there's rain and clouds and occlusion and dissipation of light and so many factors, pollution and other factors when you're so close down to the ground. That you're not going to be able. I mean, it would be impossible. Think about what it would be like if you were like on the ground in the UK. If you could see like the entire country of Africa, it doesn't even make sense that would fit in your field of view. Like you wouldn't be able to sit there and be, on a flat plane, and be like, oh, look at that. There's Nigeria and there's Gabon, and it's not like you'd be able to just see the every single country. I mean, we can only see like a mountain or pretty. We see very limited of
Well,
the ground.
why isn't any land visible in the photograph if it's pointing towards it? It's
Well,
obviously fallen away because of the curve of the Earth, right?
Well, no. So the two views, one might be a claimed curve of the Earth. The problem with that is we can see further on certain days and not as far on other days. So it's not consistent, which then means that if you want to say it's a curve of the Earth, you have to actually say it's a refracted horizon and it moves and changes position, meaning it's not just consistent with like a physical, like if you're walking down a hallway in your house and then there's a corner, you can't see around the corner and it's consistent every time. But in this case, like if the idea of the globe Earth being like the corner of your hallway, it's not consistent. Like it changes, it's different on different days and different times. Sometimes you see further, sometimes you don't see as far, sometimes you see way further than the globe should allow, etc. But on a planar Earth, you would just be seeing in a circle on a plane, like a limited distance circle, maybe 50 miles, 20 miles, whatever. And then the rest of it, instead of the rest of the Earth being down around a ball, it would just be beyond the optical extinction point of where the ground and the sky meet, the horizon, and the limit,
Yeah.
the extinction of what you can see on a plane. And last, I'll just say real quick, like I kind of say this, like if you had like a Home Depot or a Costco or something that was like the size of the United States and you were chilling in New York, you're not gonna be able to see like somebody checking out, at the checkout line in Los Angeles, even at a perfectly flat planar Costco. It's just the angle of incidence, the angle of the horizon. There's just not enough information. Lastly, one more thing. If you go to like a basketball court and you stand up, you can see the whole court. But as you lower your eyes, you put your head all the way down to the court. Once you get your head down, you can't resolve like all the lines on the court. It all compresses, and then if you put your eyeball right down to the court, you might only see 10 feet in front of you.
So I posted the coordinates, and I appreciate that, Gio. I heard everything you said. The exact location where he was, and I was mistaken in my assertion that he'd be looking south. Seems to me, based on this, that he's looking somewhere in the northwesterly direction towards Valencia, Rome. And the entire shore can't be seen. So, I mean, it's a similar thing. I just wanted to correct my assertion that he was looking towards the south mainly, but still is peculiar that he can't see a shoreline that's much closer than from Ibiza.
Yeah, have
Than
you seen the Skunk Bay
Africa would be.
footage? Show them the
Yeah,
Skunk
I've
Bay
seen it.
footage. Okay, good.
I've seen it.
Yeah.
Yeah, I've seen it.
I've
Pretty
created a
wavy there. I mean,
mathematical.
good on it.
I created a mathematical model for the personal sphere that Gio is talking about.
Sometimes you only see the top tips of the building because most of them are obscure. So it changes dramatically. Now, but that's I know it's a
Well,
side
this
topic. Well, let me just
This is
finish.
an interesting photo. Okay.
It's a side topic, but I'm just saying that hemispherical thing. Yes, on a globe, it would imply that at some point there's some kind of curving away, and that's what's happening, and then you're looking off into space. But on a planar type Earth, it would just be the limit of what you can see, and you have the horizon and the meeting place of the ground and the sky. So I mean, and there's arguments all based within that. But I'm just saying that there is a difference in that way, but there's also an overlap if it's just the limit of the horizon on a planar surface rather than curving away physically.
The assertion from our side, I can tell you, would be that it would fade into obscurity. Right? I know you've heard something, if not that, something similar. Like it would fade until you can't see it, and fog or atmospheric sort of effects get in the way. Like right, Gio. Like that would be from our side. If it were a flat Earth, if we were trying to explain to you like what you should see.
Well, this gets into some more nuance. I'll try to be really brief, but I mean, essentially, okay, if you could see forever, like let's say there was no atmosphere, no rain, no clouds, no pollution, nothing, right? And in theory, you could absolutely see forever on a planar Earth, a perfectly flat planar Earth. Things would never set. The sun would never set. Nothing would ever set. It would just get closer and closer to zero or to the horizon, and it would go on, and then potentially it would fade away, like you're saying. However, that's in like an absolutely perfect environment with no atmosphere. The thing is, we do have tremendous atmosphere, and therefore that's why we can only see 3 miles, 5 miles, 10 miles. And the fact that we have such that dramatic effect, there is going to be a profound cutoff point. Because if you can only see 5 miles of the ground, the last little bit of ground you can see, that's only 5 miles away, whether it's water on the ocean, whether it's a mountain, whatever it is, 5 miles away, and then the rest is sky. So we can't see forever like that. You can't resolve, so yes, it would fade away like that. It would always approach zero and things would never set. But if you can only see 3 miles and you're on the ground, then yes, things will dramatically set on a planar surface into that convergence point of the ground and sky.
Right.
And another point that comes contingent.
Let me finish that, and then you can go. So if and I literally just replied so that people can ping up to the image. If we were looking out, let's say we're on the edge of, let's just call it Antarctica. I'm not Antarctica, excuse me, Alaska, or top left of Canada, and we're looking sort of in the direction that yours implies if we're looking south. Would you agree that you would see a drop off in a curve, such was demonstrated by the photograph that I initially showed? I'm not saying that it's a point against flat Earth, but would you agree that there would be a drop off in the form of a curve if we were looking straight out from our vantage point that would cause it to be lower on the left side and the right side of the edge of where we're looking out? Such as the Ibiza photograph, and I can drop it again. Again, this is not a trick question, and it's not meant to like say, oh, this is globe Earth, but I just want Jeremy, if he's still here, to say, yeah, that's expected behavior. If it's not, I want to know why.
Well, I think Zinact, I always call him Seact, but Zinact, I'll try to. You prefer I say Zinact instead? Because I think your name was Seact before. I mean,
Address your point.
I've mentioned the circular hula hoop like 5 times. I mean,
So it's neither globe nor flat. I gather that you're saying that it's not good proof either way.
No, I didn't say that either. I've pointed out that a flat circle hula hoop will appear to have left and right curvature. So if we see in a circle, like Seact was saying, and there's a limit, and that's our perception, and we see 3 miles out, let's say, and there's a limit at 3 miles, that circle around you is akin to a hula hoop on a globe or a planar Earth, and all those points are coplanar.
I've got one more question. Does the horizon in the background, look very closely at the photograph I supplied, open it up, look at it carefully. Does it appear to be crisp?
If you mean by crisp that this is a good presentation,
is it fading into the point where it sort of drops off? Is my question, and it's for Gio. You can go after Zenek, but I'd like to hear Gio's response.
Okay.
Well, Seact's been trying to get in for a minute. What do you mean by crisp? The differential between the water layer and the sky layer, is that crisp? Defined as crisp, you're asking?
Sure.
Not particularly. I wouldn't use the word crisp. It's I mean, there is
somewhere between.
Yeah, I mean, there is obviously the ground and sky.
That's fair.
Layers.
I have 5 to 10 minutes before I gotta go. So if I may,
Zenek, go ahead. I'm sorry. I didn't want to belabor the point, but I wanted to just drive it home. Go ahead. Thank you.